So I'll start right away. A lot of my messages actually have been already given as well by the previous speakers, right? So I'll try to combine that in the view a bit from an IP router point of view, right? So I took the title just to be a bit, well, to attract a few people, right? So it's complicated, doesn't mean that we can't solve it, but it's not as simple as what some people make us believe, right? So that's kind of the main thing here. So I have a technical problem.
Oh, I see. It's a PDF? No. Oh, I didn't do the right job.
Okay. So it is complicated to start a presentation. So the short agenda that I have here is, so I'll start, of course, so what is the driver for all of this, right? So the main thing being IP traffic is growing, and we're all looking for what is the best possible way to build a network that is scalable and these days also sustainable, right? And then, of course, the elephant in the room is the pluggables, right? The coherent optics. And so I'll talk about how we get these things combined. And then at the end, and that was already covered a bit, is also the importance of the whole coordination and automation piece, right? So start of everything these days is there is more IP traffic, right? So it's not, I think it's not a big surprise there. But at the same time, we try to carry all of this IP traffic, but in a more scalable way than so we're looking continuously at ways to make the network more scalable as an entity, as a total entity of IP and optics together. But then don't forget the sustainability aspects, right? So these days, especially 2 years ago, it was really about the sustainability in itself and being green and so on. I think with the current evolution or the evolution of pricing that we've seen for power, we feel more and more pressure from customers to see, okay, what is the best possible way, also from a power perspective to get there, just because it has a monetary value, of course. So from a router point of view, we had an incredible increase of capacity. If you look at it's multiple generations of our systems over time, and it's incredible how much power, how much more capacity that we got over time, right? We have you can come to our booth, we have a system there, pizza box, 48 ports. All of these ports can do 800 gig, and in the footprint that is like a pizza box. It's incredible. This is a bigger system. The evolution over time is again more capacity. You see the numbers there, right? So 144 times 800 gig we will be able to do in a chassis by the end of the year, at less power than what we were having before, right? So sustainability is fine. From a router point of view, we've done a lot of things there. And of course, what our customers are calculating is what is my power per bit, so how expensive it is power-wise to transfer the traffic into the network. And then you start seeing that actually the optics are consuming relatively more and more power over time, right? So the part on the total power consumption of the optics becomes far from negligible, right? So what is the evolution on the optics side? We're knowing that on the router side, we try to get to higher density, higher scale, and less power. On the optics side, again, elephant in the room is the coherent optics. Finally, we've come to a point where we're not penalized by doing IP over DWDM on a density side of the router, right? So that has been kind of our blocker for so long. And finally, we're at the point, so you see the graphs here where the evolution of client optics and coherent optics, finally, timing-wise, they more or less come at the same time, right? And so that is one thing. The second thing is they are they allow open networking, right? So these things are standardized, so you can actually put the same coherent optics or compatible coherent optics on both sides of your line, which for us, router specialists, IP specialists, it's kind of normal. We've always been used to that. In an optical world, it's maybe a bit less natural to have this, that you don't need a bookended solution that you can do end-to-end. So we're there, the technology is there, so the question is, what is the best way of using the technology into your network? And the logical thing is, of course, that you have two options, right? So you can, if you look at the classical way, what you see on the left side is we put client optics, gray optics into the routers, and then we go off on a dedicated transponder. And we happen to be, well, we are both a router vendor and also kind of a market-leading optical vendor. So we see very well both sides of the puzzle. And then with these IP or with these coherent optics, you can actually go directly into the router, right? So no surprises there. What we call coherent routing, or what we think is needed to be able to fully use the potential of the technology, is multiple aspects. The first aspect is purely from a router point of view. It's nice to say we're going to put this pluggable now, this coherent pluggable directly into the router, but it consumes more power, right? So you need to have a router, a system that can actually tolerate all of this increased power that you will use from these optics, right? And that has to do with the design of your system, right? So you cannot really, or based on the design of your system, you can either or not put all of these pluggable or these coherent pluggables in any cage that you have in the router. That's the flexibility you want, right? So the router is the first part. The second part is, of course, the pluggables themselves. We believe that just the pluggables that we have today into the market, and there is more coming, of course, is not going to be covering all possible use cases, right? So you need to have that flexibility that, depending on your use case, your scenario, your distances, where the traffic is going, you want to have multiple options, right? So that's the second part. The third part is, of course, the line system side, right? So that's also why I called it like, let's not try to make it too simple, right? So it's complicated. Why we see, or because you cannot just remove this optical layer, ROADMs replaced by routers. It sounds very simple, but then think about the sustainability. I'll come to that in a minute. And then the fourth aspect is becoming more and more important. Discussions we have more and more with customers about the topic is really, how can we make these domains interwork correctly? So we've been talking about this for many years. What our thought is really that the availability of these coherent pluggables is actually allowing us to go to use cases or kind of revisit all of the use cases we've been talking about for years, right? So it's kind of a starting point to look at things we can do in addition. Similar slide you've seen in previous presentation, right? So depending on the use case, depending on the scenario, distances, availability of fiber, where the traffic is going, you have a selection of options, right? And you need to keep these options open, right? So depending on where in your network, it might be that 400ZR is the perfect match. It might be completely opposite. You might need more distances, or there might be more ROADMs that you need into the network. So we have this full kind of flexibility. Each of the choices you do has an impact on the sustainability, on the power side of things, right? So we keep it open, right? So you look at the technology you want. It was already covered before as well, right? If you look at kind of the naive way of using coherent optics into routers, is that you do what is then called hop by hop, or routed optical network, or whatever is the name these days. You put a router in there just to the relay to cover the distance. It sounds like an easy, I mean, for an IP guy, it sounds like a very easy network, right? I see only routers. I don't care about the optical network underneath because there is none. It sounds very simple. We think it is not. If you, depending on where the traffic is going, if most of it is just 400 gig transit, why would you do that? It doesn't make any sense, right? So that is what we call express forwarding, where depending on where the traffic is going, it's right to go through the router, but a lot of the traffic we can just go through, right? So it's a combination of kind of the most optimal thing and still being able to cover all of your use cases. So purely power, I've been talking about it a few times. I think in the previous presentation it was not really that much highlighted, but we see this purely from a power perspective. Just doing a hop on the IP side will cost you 100 watt. whatever you're going to do, even you take the smallest box possible, if you do 400 gig on a router, it's going to cost you 100 watt. Right? If you do the exact same thing on the optical layer, it's going to be much less, and it's really much less. Right? So you see the number there. A few watts is actually the cost of transferring this 400 gig across. Right? So that is one aspect. Second aspect that is sometimes forgotten is that if you build a ring and all of these nodes into the ring need to transfer all of the traffic, right? Because if you do everything at a router level, you will have to, well, you will have to put many more 400 gig interfaces to make it possible. However, if you look at, especially in an aggregation network, in a metro network, the boxes that are kind of optimized from a router point of view are not necessarily the boxes that have these 400 gig interfaces, right? So you might be challenged by the fact that you cannot put any single router there because it's still, what is available in the market with respect to number of 400 gig interfaces will just not make the model possible for too many, when you have too many nodes into the ring, right? So you need to take that into account. So there is a kind of a comparison between the two models purely from a router interface point of view, right? So that is definitely play there. Conclusion out of all of this is we need to find the best possible way of getting the traffic across, right? With the sustainability in mind. What is clear is that between IP and optical experts, and I still feel that in most of our customers, the two are really, there is not that many customers who have kind of the same person configuring the IP address and doing ISIS, OSPF configuration, BGP configuration, MPLS, and so on. Having that same guy think about DBMs, channels, and so on, it's a bit of a stretch, right? So what is important is on the gray, if you look at the classical model with kind of gray interfaces, of course, it's good when they talk to each other. Sometimes this is done with spreadsheets and so on, but typically it is different teams. And what we think is when you go to coherent optics, that interface is going to be even more important, right? Because now you're going to have this pluggable into a router. The pluggable is actually configuration-wise much more depending on what's happening on the line system. But so it's much more important to know about all of this information, to have actually the optical guy configure the pluggable whilst it goes into a router system that is done by the IP guys, right? So the coordination between the two becomes much more important than it was before. I just take like kind of the evolution of complexity, let's say. If you just do pure point-to-point, it's easy, right? The router guy for an optic for the router guy is the line is up or not. It's as simple as that, right? So we don't really care too much about what's happening exactly with channels into the network. And then the more complex your scenario becomes, the total network, IP plus optical, the more the coordination is required. Right? The last thing you want is that the router guy puts like a 400 ZR plus into the router, and because of that, there is another channel, another optical service that is completely not possible anymore. Right? So that coordination becomes important. So that is kind of a given, and 400 ZR plus drives us there, right? That coordination to make it more possible. The way we see the solution is that, well, we have today, if I look at it from our point of view, we have a network management system or a controller for the IP side. We have one for the optical side. And these things need to interwork. Right? So we want to give customers like the overview. The IP guy should know enough about optical network or see enough about the optical network. The same is true for the optical guys to see what type of IP services are going on top of his optical network. And the way to do that is to integrate the two tools. And the interface that we're using for that is a TOPI interface, which is standardized, which at the same time allows you to do multi-vendor. So it doesn't need to be Nokia on both IP and optical side. It can be an optical network from another vendor. And we use the TOPI interface to communicate between the two tools. And what you see in the arrows, so everything is going to be netconfig for configuration. But what you see is actually the optical management tool that configures the pluggables into the routers. Why? Because it also needs to be able to see the amplifiers, the ROADMs, and so on, to be able to do the full management on the optical side. Right? So from an operator point of view, it will be integrated, but in reality, it's actually two tools that work together to make sure that both sides can see what they need on the other side. Right? And once you go to that, once you've given that or you use that as a starting point for 400ZR, then you can look at all of these other use cases that we've been discussing for so many years, why IP optical integration would make a lot of sense. Right? So you have, starting with topology discovery, how are they connected? That on its own, for a lot of our customers, is already a good step forward. Right? So knowing, for the IP guys, knowing exactly to what optical systems they are connected is kind of the starting point. And then you can see a whole list of functionalities, a whole list of capabilities that become available after that. Right? So from diversity analysis and so on. So I'm not going to go through the whole list. I have just a few examples in a bit more detail. So topology discovery today, or the alternative today, is really spreadsheets. That's what we see with most of our customers. Right? So they talk to each other, IP guy, optical guy, with a spreadsheet, so that they both fill in their columns on how they are connected and so on. Of course, what we need is a more automated system that you build a new optical link, and then automatically the IP guys know exactly how that optical link is implemented, to what it is connected, and so on. So that is the first step, the discovery. Once you've gone to the discovery side, or you've done the discovery, then there is, the first thing is the assurance side. Right? So what we want to, or what we're getting to, is that our customers are managing the network from kind of the IP point of view, and then they do like a root cause analysis. So there's a problem into the network. They're trying to find out, so where is the root cause? And then being able to extend that into the optical network so that they can actually see what optical equipment is causing the whole thing is a big step forward on the assurance side. Right? So we're today, again, it's quite difficult to, with a spreadsheet. So you want to have this automatic information sharing, that when something breaks, that I can find out if it's where the problem is, including the optical layer. Right? So that is it's one of the, typically when we talk to customers, it's actually one of the first things they look at, that capability. But then you can go further, multi-layer analysis or what-if analysis. So what happens if this optical link will break? What happens if this fiber goes down? What is going to be my impact on my services, my layer 3 services that I'm building on top of this network? Right? So the correlation between the two helps me to do a full analysis of where do I have pain points, what is the alternative, where do I need to create more connections to get more resiliency into my network. And so what you see here is kind of a combination of the two. Right? So where maybe if I would only look at the IP layer, I think I have a very redundant service, very resilient. But then in reality, when I look at the underlying optical layer, I see that they actually go onto the same fiber, right? Which might be unseen by the IP guys, and actually literally customers telling us, okay, this happened 2-3 years ago, we had this problem, and we thought we had redundancy, and it turned out that when both circuits went down at the exact same time. Right? So it's that visibility that, or the visibility allows us to get this type of information. There is the coordinated control side, right? So you want to service one of your nodes. What is going to be the impact on my service, on my IP services, right? So it's another one that is a very good example. And then cross-domain connection management, yet another example. Because we use the TAPI interface, it's multi-vendor, as I said, but it can also be used for multi-domain. So meaning I'm doing a TAPI interface with multiple controllers on the optical side, so optical controllers, and then my IP management system is connected with all, and I can do this overlay information for my IP services that are crossing multiple domains. Right. So just a subset of all of the capabilities. I didn't talk about like a PCE case where you can optimize traffic not only on the IP side, but you take into account what's happening on the optical side. So many cases are available there. So to conclude, first of all, we cannot ignore what's happening on 400 ZR+, right? It's an absolute interesting technology. From a router point of view, we do everything to make sure that we can put these optics in any possible cage into our routers, right? So the way we've designed the routers with respect to cooling, we're ready for 400 gig ZR+ in all of these cages. Actually, we're ready for 800 gig ZR+, when this will be, or ZR, when this will come. Right, so I think that's the first step, the pluggables. The second thing is that let's not be too naive in how to use it. Right? So from a router point of view, it looks as simple as just putting in the pluggables and connecting them over 500 kilometers and everything will be fine. It's a bit more complex than that, right? So we think you need to look at the full picture and be able to, to manage it correctly. And then the last thing is, well, okay, this is the conclusion of, I think, what I've tried to cover for the last 20 minutes is that yes, we can use the technology, but let's not make it more simple than it actually can be made, right? So it is not, IP optical integration is not just removing the optical network, right? That is not integration. What integration is about is try to use the optical network in the best possible way, but allowing people, the people managing the network, the use cases that are running on top of the network to be integrated, to take each other into account. And I think that is a much better proposition than trying to be as simple as possible. With that, I'm done. Justin?